Cool. DJ, you will be remembered by generation to come there.
Really? Not just from your multinationals?
Keep talking so it's going to record you.
So if you guys can go please to chapter 4. Chapter 4, if you guys remember yesterday, what did we say yesterday? We said there are 9 steps for estimating, 6 for estimating and bidding, 6 for estimating, and the rest of them will be 3 for bidding. 9 steps. This chapter takes the estimating, which is these 6 steps, you can argue 5 or 6 steps, and just digest them more. Really is. That's what they're doing. They're digesting the estimating process more. With this, so we'll talk about the estimating process a little bit more digest. Do me a favor, guys. Have your book open, the estimating book at page 45, and see what we need to do today. Here's a couple of things we hope to know is what's the difference between estimating and bidding. You guys learned that yesterday. What's the difference is profit. That's it, profit. Estimating is how much would cost you, Spencer, to build the building. We're paying everything. And bidding is how much are you willing to sell it to the customer. Are you willing to sell it to the customer with the same amount of money that costs you with 0 profit, or are you willing to go a little bit higher to get some profit? So that's estimating and bidding. Based on our authors, why do you have to be selective on the jobs you bid for? Somebody like DJ goes in, there's a nuclear plant being built in Arizona, and he goes and bid on this nuclear plant. He have never been in one, let alone wire one.
$20
So,
an opening.
$20 an opening and go wire a nuclear plant.
Stay working.
Why do you have to be selective? Why do you have to be selective? How to prepare the estimates. We're going to talk a few things about that. And what to do if you do not understand the blueprint and specification, assuming you are not the generator, the developer of these specification and blueprints. If you're a design build company, guys, you can design it. And the project that we have right now is a design build. You guys design it and you built it based on specification. So you're going to know it inside out. If I give you an already designed and developed project, what happens if you don't understand something in the blueprint and the specification?
Wait.
You're going to call it, but how are you going to call it and look professional? Not every time you see something and you pick up the phone and say, that son of a gun engineer doesn't know what he's talking about. Estimate forms and worksheets are very important, guys. This book has a really nice estimating forms and worksheets that help you being organized, to help you get organized as you move through your estimates. A couple of other things. What's a takeoff? Anybody can from yesterday? What's a takeoff? Counting components and measuring distances for equipment. That's it. Takeoff. And how to determine the bill of material for the job. We'll talk about this one. Pricing, material, and laboring, performing the extension and the totaling. So we talked about pricing. What's pricing? Assigning a price for the equipment. What's laboring? Laboring is not delivering labor. Delivering babies, right? That's laboring, isn't that? Uh-oh, are we there? Not having a baby laboring. This is laboring as in assigning a labor for the equipment, for the material, right? Now what they call it, laboring? DJ.
Yes, sir.
You didn't go through that, do you?
No.
Okay. Okay, we'll stop right there. Okay, estimating, my friends, is consists on determining the estimated material cost and labor hours. So that's what estimating is. How much will it cost you? When we build a project, guys, the project is divided into 2 things, material and labor. Material is dollar, labor is hour. And how do I convert hours to dollars? How do you convert hours to dollars? You assign a dollar value for every man or person hour. So that's estimating is. Adding the material cost and the labor hours after you convert the hours into dollars. We talked, guys, about this one. If you are to be a good estimator, this is a nice term. mentally visualize the electrical installation in the building. You've got to be able to mentally visualize the installation of the equipment. Material required, knowledge of the material required is very important, guys, but to be able to understand that if you go in the wall, you have to go up in the ceiling 8-10 foot and run over down to the panel maybe 6 feet, because with most of the time when we do takeoff, guys, we're doing takeoff on 2Ds, right? You look at 2Ds, but you're taking off a 3D, so you have to drop down every time. You have to understand if there's an outlet right in here, and if there's a panel right in here, and here's my panel, and here's my outlet, and it's circuited, this panel is circuited to this outlet. You have to understand that you have to go up, over, and go down again to this panel in 3Ds, right? In 3D. Very, very important. If you don't have this ability, you will be a good estimator, not so good though. Basic form. A couple of things, guys. Again, back to these are the same 5 steps that we discussed in chapter 3 yesterday. Basic steps of estimating process. Remember, it was 9. Just concentrate on the 9 that we did yesterday. They're taking 5 of them plus the summary and putting them in this chapter. So estimating process. Number 1, understand what is required to be understand the scope of work. Remember how we did understand the scope of work? You have to. You can't just go without understanding the scope of work. Now, after you understand the scope of work, what do you need to do? Count and measure. Count equipment and material and measure distances. Measure for cables and feeders and branch circuits, and count for devices and lights and fixtures and so forth. Number 3, after we understand what we need to do, we counted everything, we put them in nice sheets, nice forms, and we assigned them determined material required for pricing and labor. Then we put them in the bill of material. We generated the bill of material. We like we said yesterday, we counted how many receptacles, how many generators, well, how many lights, I guess, how many switches, put them in a format, and that will be the bill of material, my bill of material. After you have your bill of material, guys, your bill of materials just counts and distances. It doesn't have price and labor. You assign a price for the equipment, and also you assign a labor for the equipment. This receptacle is going to cost me $1.50, and to install it by DJ, who is well qualified, well trained, highly motivated individual, it needs 0.05 of an hour. 0.05 of an hour. Get fired. So that's the last step. The last step, guys, is after you do the pricing, assign a price. Where do you get the price? Vendors or software. Softwares get the price from the vendors. Where do you get the labor? Labor is organized labor, like NICA guys have a standards where you can buy their labor units, or you can develop your own labor units. After you do that, you do the math, extending and totaling. What's extending and totaling? 5 receptacle, $5 each. That will give me $25 for receptacles. 5 receptacle, half an hour each. That'll give me 2.5 hours to install 5 receptacles. That's what extending and totaling. Extend them and total them at the end. Any question, guys, about these 5 steps for estimating? 5 steps for estimating. Yesterday we added one more. We call it the estimate summary, where we group them together. It's estimate summary. 5 steps for estimating. Questions? Questions, my friends, about that? Common sense, right? Common sense. Okay, moving on to job selection. This is for you. Who am I going to pick? I keep picking on DJ. I'm going to pick on Brad today, so you get mad. Before you estimate any job, you're going to ask yourself, guys, a couple of really good questions. Is this the most efficient? If you don't care about your time, why should I care? But we're all busy. Do you really want to waste 2 days of work on a job that you know for a fact you would never get it? So before, these are good. I agree with them. Good suggestion is this really the best use of my time? And instead of going golfing or chasing other jobs, should I sit for 8 hours or 24 hours estimating this project that I know for a fact I would never be able to do this job? because of my expertise, because of the location, because I can't finance it, because I don't have the man hour or the person hour. Talent, am I smart enough to be able to pull this together? You know, we're all smart, but are we smart on this particular field and skilled and I like this one, at this time. We might be smart and skilled and everything, but at this time we're completely overloaded. Do I need to go overload myself with another project that I know for a fact I'm not going to get, and if I get, I'm not going to be able to deliver? So these are questions in this market, guys. Now, this does not apply to this market. Everybody now wants to chase everything. So the idea is you must always be selective about which jobs that you can choose will be better to meet your financial goals. So long story short, you're not going to be throwing. You've never done medium voltage. There's a medium voltage high line that's going to a city. Would you go bid on a medium voltage that you have no idea how much it's going to cost you, labor and material, waste 2 or 3 days, working days, knowing that you don't have the skills, the money, or financing? So that might not be one of your finance goals. The suggestion, these are common sense. Always go after anything that you have reasonable chance of making some type of a profit or float, break even at least, not go under. Always chase anything that you don't have a chance of getting profit or float. You don't need to chase it. A couple of suggestions, guys. I hate that word, gut tell ya. Ask yourself, these some suggestions before you bid any. What does your gut tell you? Am I going to be able to do it? Am I not? The chances of getting the job. Do I have a chance of getting this job that I don't have expertise in, or I don't have money to finance? Am I going to make money on this project? Am I going to be able to finance this project? So these are a couple of things: financing the project, profitable, making money, getting the job, because you don't want to waste, guys. Estimating takes a lot of time. You don't want to waste your time, especially if you are busy, which a lot of successful electrical contractors are busy people. You don't want to burn 16 hours or 24 hours of work for nothing. Common sense. Any questions, my friends? Bill, my friend, any questions? No?
Do you have the CD with all the forms on CD?
No.
They have it online. They have it.
You have them online?
Well, they have it. You can get it now. They didn't have that when it got to book.
Okay. The forms that we have here.
Out of here.
Absolutely. So these are now what we're going to do, guys. We're going to digest these things deeper. They're just going into understanding the scope of work. Sure, you have all the information that you need about the job, common sense, understanding the scope. They're taking each one of these tips and digesting it a little bit more. So get all the information, complete, and set a blueprint specification. Very, very important, guys. You don't want to take off using a blueprint that has been revised. So make sure you have the most current blueprint and specification to work off. Otherwise, you're going to be missing a floor or missing an equipment. So these are the items that you ask yourself under, have I understood the scope of work? By asking you a question. The other ones, be sure to visit the job site before you bid the job. It's a good idea if you have the time, drive around and see, is this downtown Minneapolis where your electricians are going to be landing half an hour trying to find a place to park? Job folder. Being organized. Remember, guys, what we talked about? Job folder to contain your bid paperwork. If you want to be a successful electrical contractor, and you can argue with this, successful electrical contractor estimator, managing your time, guys, and being organized is, I think it's a big deal. So having a folder for every job. I worked for an engineer that has a folder for every job, and a folder in the folder for communication. When he makes a call for the client, he write down the summary of that conversation, put it right into communication with the client. So you call him about any project 5 years after they finish the project. The customers do. They call you about certain things. You pull the information directly from the project. So what better than that? And why this is important, guys? It shows when the clients, remember, Your job, DJ, is to do the job and convince the client that you're the best and the brightest, and they will call you forever to do this type of jobs. That's your job. So being professional, being organized, being at the top of your things, hopefully that will guarantee you repetitive work. That's the whole idea. It's not just finish the job with the hell with you. You want to finish the job, and every time they do, first get the maintenance contract from them, and every time they think of a job like this, hopefully them or others, they hire you or they recommend you for others. That's our job, guys, as an electrical contractor. Create and complete an estimate record worksheet. Estimate record worksheet, page 60 to 69, guys. Very, very important. You can argue what the information in it, but it's really, if you guys look at it in page 49, it says estimate record worksheet, job information, job name, job location, job owner, bid due date, city, phone, info. You're working on a project and you have no idea when the bid is going to be due. I mean, isn't it nice to have a sheet like this? And you can make any sheet, but something sheet already organized like this to have all this info in one place. Plans and specification details, date of the plans, when they were published, blueprint numbers. Are you guys with me where I'm looking at that sheet? Comments, any comments? And instructor jerk or inspector is really a hard inspector. A lot of comments, guys. Some people have comments about the inspector, hard inspector to deal with, you know. So if I'm looking at it, I might have to electrical contract. There's some inspector who are picky a little bit. So you have a comment that says hard inspector to deal with, or hard engineer. Some engineers are, you know, kind of rough around the edges.
Okay.
I didn't say that. Contract, then you have the contractor information details if you are not a contractor. Your contractor address, phone, beeper, do they still have use? Cell phone maybe instead of beeper. And contact, city, email, all information related to the project, guys. Contact information there. Important contact, who's the architects and what's their phone number? Who's the engineer? What's the phone number? Who's the utility? Excel, I don't know if you guys dealt with Excel. Excel divide their territories into areas, and every engineer is assigned for one area. So if your project is in St. Paul, most likely going to be dealing with X engineer. So get the phone number immediately. And these are published information. So you can, if you have a problem, do I have enough juice coming to my plant, that area? How am I going to get temporary power to this plant? So very, very important. Utility, telephone number, electric utility, is it Excel or Minnesota Power, or where am I? Which territory am I in? And electrical inspector, very important. As you start building the project, guys, remember, your job is to estimate the project, get the bid, and start the building process and manage the project and scheduling it. Don't you think a name of an inspector and a phone number would be nice? You know, if not for anything else, just buy them a meal or something. Oh, did I say that? And you write any other notes, guys, underneath it. So these are good information, common sense to fill and refer to it. You don't have to sleep with it like Chad do with the NEC code book. It says wall over your takeoff, so worksheet, and hang it on the wall over your takeoff. You don't have to do that, but put it in a place where you can get to it. Don't hide it right underneath 15 trillion info, and you're not going to get back to it. Read the specification and the notes on the blueprints. Very important, guys. I told you about people who lost the bid because they lost a floor. It says typical of 3 floors. They show the layout of 1 floor and they say typical of 3. Imagine taking off 1. That would be a big mistake. As we start doing the calculation, guys, as we start doing estimating with softwares, you're going to see DJ, 1 multiplier, you take off everything on 1 sheet and you multiply by 2. So if you made a mistake by accident, you took off 1 floor and then there's a slot where you can put a 2. So now you multiplied your estimate for everything they did by 2 without knowing, if you don't know how to use the software. Just mistaken using a software. There's a place where you can put 2. It's supposed to be 1, and accidentally or whatever, you put 2. Now multiplied everything they took by 2. Imagine how your price is going to be much higher. You're not going to get the job. So that's as bad as getting the job and not being able to get profit out of it, right? Keep track of the questions. Again, questions, guys. The worst thing that could happen to any one of us, guys, is every time you're doing the takeoff and you have Chad emails. Chad is the engineer on the project, and every time I don't understand something, pick up the phone, call Chad. I answer the first one, the second one, the third one, the fourth one. I'm not in the office. Guaranteed. So people are busy, guys, and they don't respect other people who are just, you know, you get to group it. The idea is you have questions, write your question on a piece of paper, go over everything, and then write them down, call the engineer or the architects and ask at least one time, maybe twice, but not every time you're stuck with something, you pick up the phone and call the engineer. You drive them nuts, right? And you show that you're incompetent. That's another thing, right? You're incompetent every time. Well, what is this on the plan? Maybe you should ask your colleague before you bug me, huh? Even if I'm wrong, you know. Um, get it as soon as you can, but don't drive people nuts. You don't want to sleep on it. I've never done estimating on a larger project, guys. But if you have any problem, what I would do is write them down and don't sleep on them though. Don't write them down, go home and sleep, and no, we'll do it. Call them tomorrow. Immediately after you're done with all your questions, went through them, write them down, call the engineer, the architects, get your answers as soon as you can. Um, specification checklist. Specification checklist in page 52. Can you guys go to specification checklist? Things, guys, that you need to do. Hang it over, take off. Things that you need to check. Have you covered as you start? And we're not talking about $1,000 bid, guys. We're talking about $1 million bid or so. So this is a checklist to get you on track. For example, labor units. Specification checklist. Do I need to adjust base labor unit adjustment? We're going to talk about this one. Remember how we said, guys, labor unit is 1 hour to install this fixture. Depends on normal conditions with normal people and so forth. So you need to adjust this one. If I know, just to give me an idea that I need to do some adjustment for my project, this is a nice checklist to keep track of. Building conditions, change orders, blah, blah, blah. Read through all of them. The minute that you put a check, this means when you're done with your estimate, you look at it and say, you know what, there's an issue with job factors. There's issue, so I might have to jack up my prices slightly or lower it. Overtime, remodeling, and a whole lot of lists, guys, that comes into this job list. And here's a few of them. So if you look at additional labor, do I need additional labor? Look at the things, almost the same stuff. Do I have to add additional labor for 1 to 19? Direct job expenses. Look at the direct job expenses that they have, guys. They have as-built plans. Do I need to add money for as-built plans? As-built plans, when you're done, Brad, you have to redesign it, because in the field you modify things. You have to put all your modification back into the design and send it to the owner, so the owner has an up-to-date version of the project, not the one that got modified during the construction. So anything you modify, you keep track of it. Then you redesign it again, put it in the plans, and send it to the owner. But who's going to pay for this time? Do you need to do as built in? Yes, then add money for that. Engineering drawings. Do you need to pay $100, $200 to get a set of blueprints from the engineers? Add it. Field office expenses, fire seals, and a bunch of other things. You can read through them. Other final costs, back charges, bonds, financial costs. So all these things, guys, it's a nice list to keep track of. You might not understand each and every one of them, but it's really a nice list to checklist to see, oh yeah, I might have to add this here and there and there. Other consideration, conductor size minimum, conduit size minimum. It's not, you can't guarantee that everybody can use. Some engineers don't use list number 12 copper. You don't want you to lose number 12, list number 12 copper. Even if you can get away with number 14, they don't want you to use number 12. A lot of engineers, guys, don't use less than 3/4 inch EMT, even if you can get away with 1/2 inch EMT. Don't put it underground. Don't put anything underground less than one inch. It's not worth digging a trench and putting a 3/4 inch PVC conduit, less than an inch. So where do you find this information? Specification. So these are the checklists, guys, to help you, as I said, to help you go through and make sure that you accounted for everything else. A couple of comments here about the plans and specification. Be sure you have every page of the blueprints. Would that help, huh? Every page of the blueprints. You're missing 2, no problem. Specification, get everything that you need about specification. Additional requirements, specification are additional requirement. Visit the job sites. So a couple of things that we covered, guys. Prepare for the estimates, job folder, estimate record worksheet, plan and specification review, an estimate, and bid notes. We're going to talk about this one as we go through it. Estimate and bid notes. We we will talk about these guys in a second here. I'll walk you through the estimate and the bid notes, but let's just go over the one. So we got ready to go, and specification checklist. All right, takeoff. So that's just the first chunk of things. Is just getting you warm up for the takeoff. Takeoff. The worst thing that could happen to you with the takeoff is get confused, not organized. One time, the best thing to do, the best takeoff, and ask any one who guys do takeoff by hand. And by hand, I mean you can have a counter, that's called by hand, or you can have a wheel, that's also by hand. Electronically, there are softwares that can take the information directly from CAD. But there's a lot of coordination to do that, directly from CAD into the estimating software, directly from as you draw the circuit. It assigns a family for it, an assembly, and it takes it directly from the software. Most of the people do it by hand, either by counters, guys, or probes or whatever. If you do it, you have to have a system of taking it, so you can check your work, meaning color. As you take off receptacles, have a color for receptacles, a color for lights. So every time you see red, oh, I know red is a receptacle. So if you, that will help you. Your job is to take off everything, not to miss anything. And at the same time, if you made a mistake, to make it so easy for you to find your mistake. You know, that's kind of the idea. So quickly and accurately, that emphasizes quickly and accurately estimate the job. That's where the forms and the worksheets comes very handy. Forms and worksheets, not enough just to sketch it there, and if you made a mistake, God forbid, it will take an act of God to figure out where your mistake is. Proper forms, guys, the whole idea about the forms and the worksheet is create consistency, assist you in reduction of error. Your job when you do all these forms, when you use the forms, guys, is to do it fast, quick, accurate, and if you made a mistake, you'll be able to track that mistake much faster. Common sense. As we go through the takeoff, guys, going to see some suggestions. Remind items that easily. Forms also can help you to anything that forgot, anything that you've forgotten. Low voltage. If you have a form for low voltage and security system, you have a form for security system, and you look through all the plans and you don't see any security system, that will be a reminder. Said, are they having a security system in the building or not? Well, that's worth a call. Maybe you're missing a low voltage sheet. What is the takeoff? I summarized it, guys, by the act of counting and measuring symbols. Counting symbols and measuring distances, right? The idea when, so you count it, you measure it. The idea when you do the takeoff is never to come back to the plans again. Because remember, you're going to be fast, accurate, and you can't believe when we bring Parson here and talk about estimation, guys. You wanna walk in fast, quick, accurate, get all the information, come out, and if you made a mistake, you need to be able to get in, correct your mistake, come out, also fast and quick, and not retaking the project over and over again. Little need to go to the drawings or specification. When your takeoff is done, guys, and you pulled all this info directly into the software, it should be color coded so you can get back and fix your problems, and you should not need to go back and pick, oh, okay, I forgot receptacles, okay, I forgot GFCI receptacles or tamper resistance. So you need it to be complete, accurate, put in information, leave it. If you have to go back for accuracy, or if your boss wants to go back and check after you, should be in a format that anybody can check it. To do that, you need to have an orderly, organized, methodical routine, and use it job after job after job. The worst thing that could happen to you or the firm, guys, is every time we have a project, we take it up in a different way. I don't know about you, but imagine if every time you want to come to Dunwoody, you have to use a different highway or different way. Don't that confuse us? A human being, I don't know about you guys, but most of human being like Chad, like routine. Routine make us feel comfortable. We know expected. I know when I go to my house in Bloomington, which highway I'm going to use. You know, it makes you feel comfortable. The same thing when you do a takeoff. If you do a takeoff, every time you red, one time you use red for receptacle, the other time you use red for lights, and the third time you use red for switches. Non-consistency create, for most of us, it create panic. So you need to be consistent, organized, methodical, orderly, if you want to be an estimator. If you want to be an estimator. So does that make sense, guys? Does that make sense? Common sense? No? Consistency? Identify item that you have taken off. Color pencil. Very important, guys. Color, unreal. You can't just, when you start taking off, guys, I'm going to ask you to bring colored pencils or pens. So as you take off, here's my receptacle here, and here's a switch here. See how nice it is here? Here's my panel over here, you know, and then what else? I have a disconnect over here. Isn't that nice? Color code them right away as you take them off. So if I want to be taking off my switches, every time I take off a switch, I put a check next to the switch or color it with a green. So my green is for switches. It doesn't matter what color goes with what, as long as you have a standard. As long as you have a standard. It makes it easier, number one, to do the takeoff. Check your mistakes. Make sure you did not miss anything. And when you're done, your blueprint should be color coded, like kids. So you have to be color coded. So the quantities, let's just go quick into measuring the distances. So that's the counter, guys. Measuring. So we counted the equipment. Now we need to measure. Measuring, the first thing you need to do, and a lot of students here mistakenly when they do it, the first thing when you measure on the 2D, guys, what do you need to justify? The scale. The scale, if your scale is 1/4 to 1, it's completely different than a half, 1/8 to 1, or 3/4 to 1. Your scale, you can screw up, you cut yourself by half if you go from 1/4 into 1/8 scale. So that's your distances. You can make a feeder that's supposed to be 100 feet. You can make it 20 feet if you use a different scale. What's wrong with that, Chad? Now, it's supposed to be 100 feet in real life. You're taking it off as 20 feet. Big deal. Scale. You can't believe. Verify the architectural scale listed in the blueprints. And not only get you guys the listed, sometimes you write it 1/4. You have to verify it. A lot of estimators will tell you guys from past experience, they go to a door and they measure the door. This door is supposed to be 3, or they see something that's measured there and they go verify. This says 2 feet, and the scale says 1/4. Let's go verify if this is 2 feet, really. Not just make sure the scale is there, verify the scale by using some object there. An object that you know that the distance of the object, measure it. It says the scale, it says 1/8. It says 2 feet on it. Now let's measure it with the 1/8 scale. Yeah, 2 feet. Good. Let's keep going.
Not like a toilet or something.
Door, like a 3-foot door, a window that's supposed, or sometimes they have dimension and certain things to scale. Dimensions, you measure, it says 4 feet on this direction, and you go measure it. Yeah, it says 4 feet. The scale is correct. Because a lot of engineers, guys, they have scale stuff. Sometimes they give you half scale copy of it, and that will screw up your measurement. Especially for distances. For the counts, no problem. But what the problem is for distances. The idea is how should I, when I start the takeoff, where should I start with the takeoff, guys? It doesn't matter as long as you have a system. The idea is to have a system. Here's a couple of suggestions. For takeoff. What we did for takeoff, guys, with me, when we did them by system. We do the takeoff, the one that we do by system. We do the lights first, we do with the power, then we do the low voltage. Here's one sequence, takeoff sequence. You can start one section at a time, one page at a time, E1. You start from E1 all the way to E12 in our project. Start at the service and end with the light. So the another sequence, start at the service, end with the light. A second sequence. The one that we used in this project, guys, we start E1 through E12. We come through E1, there's nothing on E1. But I usually ask the students to list these, E1, and then we go by sheet. Number one, sheet and power, sheet and system. And the software that we use can list these as you go by, here's the E, these are E's, these are system, and these are building. So for example, sheet number 1, system as, I'm going to say none on it, and building A. Sheet number 2, system is on it, also none, and building B. And you keep going. Sheet number 3, guys, system is power, and building for building A. And you keep see how that you slice it by sheet, by system, and by building, and others. The software that we have is capable of slicing it by even deeper than that. Any question, guys? Any question about the sequence? The sequence, as I said, the one that we use as start by sheets. We do it by sheets. Takeoff sequence generally follows. Here's a suggestions: counting lighting fixtures and developing quantities, and that's what this book is using. The book, Michael's book, is used. First, we count our fixtures. The second one is count our switches. The third one is count the receptacles, and then measure branch circuits, and count and measure individual branch circuit, dedicated circuit, and then count and measure the systems, the low voltage systems, Just get rid of these.
You mark all your branch circuits with the color pencil.
Color code them as you measure them. So if you guys can see, I think that's the final sequence, or do we have somewhere? Okay, so if you look at the sequence this is the sequence that you guys are going to follow for this project. The first thing, you need to go to all your fixture and count your fixtures, quantities of your fixture. Step 1. Then go to the switches. Is it wrong to do the receptacle first? Second, have a sequence, stick with it. Have a sequence and stick with it. Then you do the receptacles, we'll do the measure branch circuits. Then, this is where a lot of people get confused. Then individual, count and measure individual circuits and home runs. Some people put this step, guys, and this step in one, branch circuits, not a big deal. Then count and measure low voltage, television. This is my low voltage equipment at the end. Count, and the last thing is switch gear, what we call switch gear, which is equipment and panels and service and feeders and so forth. This is the sequence that this book is using. That doesn't mean it's the best sequence. Start with the light, end up with the switch gear. Start with the light, end up with the switch gear. And when I give you guys tomorrow the sheets, keep this in mind. That's how he put his sheet, Mike. Start with counting the fixtures and end up at the bottom with the panels. Is this the only way of doing it? No, there's so many ways. The key point is have one, stick with it. Have one way and stick with it. Any questions, my friends? Any questions? They put you to sleep. It's not Monday, it's Tuesday today. Muhammad, my friend, good? How many of you guys want to be estimators, project managers? No? Raise your hands. If none of you, let's just call it a day and stop here. Not waste, go back to code. Okay, so this is really the most important thing, is the takeoff. Takeoff, oh, excuse my friend. The takeoff is, and I can't emphasize, if you guys want to highlight this one, because that's going to be doing it for me. This is the step, and I'm going to say this is step 1, 2, and 3, 4, and 5, and the last one is step 6.
Is that in the book?
That's right in the book, and you're going to see as we go through them, guys. You're going to see that this is the sequence that they're using. The sequence that they're using. Okay, determine the bill of material. Step number 3, determine the bill of material. Once we took over all this stuff, guys, once all this stuff has been taken off, you put them in a sheet and it becomes your bill of material. It really is. Becomes your bill of material. As you do your takeoff, you need to be able to determine enough information for the type, the size, and the quantity of every single equipment. GFCI receptacle, 5 of them. So I have, if I have my GFCI receptacle, and the number, I have 5 of them. If I have conduit, if I'm taking conduits, I have I have 35 feet of 3/4 of an inch EMT. That's enough information. 35 feet, 3/4 of an inch EMT. Enough information to get a price for it. Do you think 5 receptacle GFCI is enough information to get GFCI receptacle? Does it say tamper resistant? Now, if you need a tamper resistance, that's another step you need to. If it's residential, it have to be tamper resistant. If it's outside, it needs a cover, a weather cover. You know, so if you say GFCI, that's non-tamper resistance, not weather protected, and so there's nothing, because that will get you a $12 versus if you have tamper resistant and GFCI and weatherproof, all these that will run you $20 a piece. Does that make sense, guys? How to enough information to get you to take the takeoff, enough info to get you to do the takeoff. If you have a computer, which we have a software this time, DJ, but we don't have a really computerized software. If you have a computer, you don't have to worry about this. The only thing you need to guys to do when you have a computer software, understand the scope of work, do the takeoff. Everything else, the bill of material will be just generated for you from a software. Unreal, really cool. It generates all this stuff for you. For this particular project, guys, I have an Excel sheet. It has the bill of material. It's linked, but it's really awkward. So I want you to be patient as you link them. How many of you guys know how to link a sheet to another sheet in Excel? Sheet to another sheet, not a big deal. If you don't, we'll show you. So you're going to have sheet number 15 linked to sheet number 1. Very easy. Link a cell to a cell in sheet number 15 linked to a cell in sheet number 1. And because you're going to carry these sheets, so it's really complicated, not complicated, but it's interesting sheet that you're going to be using. Excel sheets. Okay, pricing and laboring. Now laboring is not delivering babies. Laboring is going to assign the labor to it. Bill of material. So you have to provide your labor. You put your bill of material, assign a labor, and the price for each one of them. To get this one, guys, you need most of them. Either you can go to the manufacturer price catalog and pencil it. You don't want to do that. The sheet that I gave you has some prices in it. You can use these prices, or you can research it and find different prices if you want to. If you're using an estimating software, which we'll be using next quarter, all these are embedded into the software. You don't have to even, well, you have to, yeah, an AccuBid or McCormick. All these are directly embedded into the software. Now from time to time, you have to go check them, obviously, but you don't have to worry about them. Labor units, you can get your labor units. There's a lot of people, Nika has their own labor units, so you can buy these labor units and import them. As you guys see, not with this next project, you're going to see that you can actually pick different labor units, Nika 1, Nika 2, Nika 3, based on how hard the work is. If the work is too hard, Nika 3. If Nika 1 will be the least hard work to do that particular job. So they go by labor unit and how hard the labor unit is. They slice it really deeper. So adding all this labor to the equipment is called laboring. If you have a computerized software, DJ, what do you need to do, my friend? Go have an app. After you're done, you go have an app, right? Go have an app. Go have an app. Okay, so worksheets, extending and totaling, adding. Now you do the math. You're going to add them up. All this good stuff. And now I'll show you this. Extending and totaling is done automatically by a computerized software. In the sheet that we have, in the sheet that you guys have, it's going to be completely done by the Excel sheet, And when you're done, if you're doing it like Excel sheet, especially, who am I going to pick up? Mr. View, my friend, if you're doing it by hand, make sure that somebody else will go double check your extension and math. Especially the math, guys. Yeah. Even if with Excel, you remember Excel is like we have always learned. Did you guys learn the same thing about computer? Garbage in, garbage out. Any software, garbage in, garbage out. You can make the Excel sheet look so nice. If you click the wrong button, it can get you completely the opposite, different or opposite results that you expected. Okay, So these are the things that this chapter guys cover. Any questions? Any questions, my friends? From the takeoff to understand the scope of work. Before I let go with this chapter and give you guys a quick break, I want you to go with me please to page 58, just to show you a sheet for takeoff sheet. Takeoff sequence, page 58, I'm sorry, 53. 53. Make up your mind, Chad. 53. 53 Fig 4-1. Can you guys see how fixtures? This is how you're going to be taking the project for me. They have the fixture. They have lay-in fluorescent fixture 18. That's a takeoff. Counting them. They're counting them. And exit fixtures 2. Switches. Look underneath them. They went switches. Switches, single pole, single gang, 1. Switch 3-way, single gang 1, and so forth. Receptacles. Underneath it, convenient receptacle 9. IG receptacles in 2. That's exactly what I'm looking for. Insulated ground. Insulated ground. That's what. Now, insulate. They want a receptacle insulated ground. What's the difference? Expensive. Yeah, dedicated ground, and the receptacle has to be designed differently. Okay, so this is one part, guys, of a takeoff. Move into page 54. Will you? 54. Page 54. It's showing you the meeting room, with all the light and receptacles in it, and they're doing the takeoff on these fixtures. Look at the legend, and how many items of each one of these receptacles. I have receptacles at 20 amp, 125. I have 9 of them. Can you guys see that? Insulated ground receptacle. I have 2. Home runs. Look at the way at the bottom. Are you guys with me? M1. That little chart over here. See how they have a 1/2 inch EMT with 5 number 12 conductors. I have 10 feet. That's the brand circuit. So they measure these distances. Moving on to page 55, my friends. If you look at the little table on page 55, they took the 1/2 inch EMT with the number 12, and they have 645 feet of it. And they add 10% wire, increase the wire for 10%. And we will talk about this one, guys, in the coming. I'm going to go all the way to page 57. Page 57, that's where it becomes a little bit awkward, this software that we're using, this Excel. Page 57. Page 57, guys, take the equipment and assign a box and a cover to it. If you are using, that's why I don't like it. It might be even actually complicated more than it should be. When we go, guys, to a software, it's an assembly. When I take a switch, Spencer, in a real estimating software, the switch means the switch itself. It's what they call a switch assembly. Switch, the cover, and the box with it, and even the wire nuts that goes in the switch goes with it. That's in a real good estimating software. This one, because it's not as good, since you take a switch separate than the box than the cover, they go in this sheet, guys, and they assign a cover and a box for each one of them. So if you look at the lay-in fluorescent fixture, the quantity is 8. I need boxes 4x4 box to tie them to 9 boxes. EMT, I have the rings, mud rings for them. No devices, none. If you look at under receptacles, look at the receptacle, convenient receptacles. I have 9 of them. I have 9 4x4 boxes for them. EMT conduit, 18 feet of it. I need rings, mud ring. I have one gang, 9 of them. And I have devices. Device itself, I have 9, and plates 9. Can you guys see that? So that's what I don't like about this little software, because it in one way it's inconvenient. In another way, it really helps you understand what an assembly is. An assembly, guys, is a switch, a cover, and a box all in one. Since we don't have a software, you have to build your assembly. Every time you take a switch off, you have to ask yourself, have I accounted for the box for it? Have I accounted for the cover that comes to it? So that's what this is supposed to cover. Okay, if you guys go to page 58, please. Page 58. In page 58, they have a bunch of details. Those of you who have never wired and they wanna be estimators, project managers, these are really good to look at. Look at detail number 1, guys, fluorescent lay-in fixture. It shows you that there's a box, a 4x4 box, and there's a fixture web tied to the actual installation, tied to the fixture. So you have to account for the fixture web. If you guys look at, I'm just going to pick another detail. Look at detail 5, which is page 59, detail 5. Single switch one gang. Look at what the switch one gang has. You have to have a mud ring, you have to have a box, and you have to have a cover and the device itself. Now, please remember, these called assemblies. Later on, guys, and when we have estimating project next quarter, we're going to be picking an assembly. So we're going to ask me, Chad, what the heck is a switch, a single pole, single throw switch assembly? A cover, as the switch itself, and the box that will be housing that switch. So if you guys look at detail number 6, if I can tell you, Brad, you're going to have 2 switches assembly. In the software, they say 2 switch assembly. What is a 2 switch assembly? It's going to have 2 switches in a box, a 2 gang box, or a square box with a mud ring for 2 devices and a cover for 2. Do you think a cover for one switch will be different than a cover for 2 switches? I hope so. Okay, so look at them, guys, and we've run all these. They will give you kind of what to think as you start taking off. I want you to think of a cover, the switch, and the box. Then in page 60, guys, they put the pricing and laboring. They added all this equipment. What does C means? Remember yesterday when you take off, C is 100. What does M mean when we do takeoff? 1,000. What's E means? Each. Every time you see, guys, like for example, receptacle, insulated ground, 20 amp, 120 volt, E. Next to it, E. It's $11. E. Okay, E means each. So if I have 2 of them, each one of them is $11. When you do extension, what does it mean? $22 for both of them. Labor, the same thing, guys. The unit for the labor is CC. C means 100. Okay? Then you go to page 61. In page 61, they do the extension and totaling. Pricing and laboring, worksheet number 2. So let me just do one example, guys. On page 61, I have a 4x4 box. I have 4x4 inch box. Okay, look how they do the dollar for it. I have 30 of them. Multiply that 30 by what's 59? $59, and divide by 100. Why did I divide by 100? Because this is per 100, and they'll give you $17.7. That's M, material. Let's look at the labor. L, labor. Can you guys see for the box? You have 30 times 59 divided by 100. That should give you $17.7. Let's look at the labor. I have 30 of them multiplied. What's the labor for each, for the 100? 18 divided by 100. Why divide by 100? Equals 5.4 hour. This is extending labor and material for a 4x4 box. Repeat. Why did I divide by 100 here? Because the unit is C, 100. Why did I divide by 100 here? Because the unit is C. Why did I multiply them by 30? Because there's 30 boxes like these. Okay?
What is E?
E is each.
Well, each and M is.
M is 1,000. Okay? So you do all this totaling, and gentlemen, all of them in page 61 identical. That's basically as hard as it gets into the math. If you have an estimating software, Holly, you don't have to do with that. You don't have to do all this stuff. Everything is done for you. Questions, Mr. Erbab, before I give you 5 minutes break. Questions. This is it. Estimating is, we did the takeoff, count, and measure. We put them in a sheet. We call it bill of material. We assign the labor to it, and we did some math to extend them. Now, what does that mean, guys? I have 30 4x4 boxes that will cost me $17.7, all of them together, and it will cost me labor for 5.4 hours to install them. 5.4 hours to install these 30 square boxes. Now, next step, Mr. Erbab, when you come from your break, we're going to take these hours and convert them into what? Dollars. Why do you think they put the labor in hours? Because I pay my electricians different than you pay. But an hour is an hour, but I pay them differently. Now I can, to convert this one into dollars, I can go assign $52 and do the math, how much it will cost me, or I can assign $25 and do my math on it based on how much I pay my electricians. Great. Thank you, guys.
I don't get a lunch break after that.
We just did a work day, so.
I know. Some of them can't make it up. Right at the end of the chapter question.
I have answers for them. I'll give you. Yep.
Online.
I will give it to you. Which one? The estimating? Yep. Okay, here's a few things, guys, we're going to learn. A few things you're going to learn about the estimating summary. Estimate summary. We'll just talk about the estimate summary. We're not going to the bidding yet. Just estimate summary. The estimate summary, the key point, guys, is adjust the labor. Now, because I'm working, it will be adjusting the labor based on the conditions. And we learned how, if you're working in a restricted action, you have to adjust it. Determine total labor cost plus the benefits. Determine material cost also. We're going to do that one, plus any miscellaneous and waste and theft. Theft is going to be included in that one too. And how to get the fixture and the switch gear price. These are the codes. If I spell that one, we'll learn how to get codes, guys. So what we did is we took off everything, we labor and price it. Now we're just adjusting it, adding a little bit to for theft, a little bit for certain things, and we're getting the price for the codes. Codes, guys, you can learn. Codes are things that you don't take off. For example, if you have a panel, a 4,000 amp switch gear, do you think you're going to have a price for a 4,000 amp switch gear that's constant between 5 vendors? Absolutely not. So what you do is you have a code. Yes, sir. We are on page 67. Page 67, Mr. Beb. Good question. And then we're going to do the direct, what they call it, direct job costs, expenses, and small equipment, rental, all this good stuff. Probably apply overhead, then we add the overhead, and we're going to come with a very, very important number called break-even number. Break-even number. That's the number that you're going to have with you when you add the break-even number. How to determine your job break-even number. Break-even number is if you go below that, you lost. That's what the break-even number. No profit. No profit. This is how much it's going to cost you. If it's going to cost me $100,000 to build this building, and I bid it for $100,000, this means I paid all my expenses, including overhead, and I broke even. Is there anything wrong with that in a tough economy? There's nothing wrong with that, but remember, we are about profit. I mean, businesses are about profit. That's how you rate them. Publicly traded business, they're all about profit. You always want to go more than break even. Break even is just for mediocre businesses, right? That's why nobody wants to be a break even business. Do you want to be a break even business, DJ?
Yeah, for tax purposes.
For tax purposes. Break even business. Okay, so these are a few things, guys, we're going to adjust here. Okay, requires adjustment. So we talked about adjusting the labor, guys. Okay, there's a couple of 8 major sections to adjust, and these are just FYI, guys, to adjust your labor units. And a couple of things. I'm gonna list them here, but I'm gonna show it to you guys. the adjustments, as you put them in a summary, you're going to adjust the labor hours. We have labor hours, labor cost. We group them. Now we're grouping them in labor hours, labor cost, material cost, direct job cost, and estimated bid prime cost, overhead, and estimated cost. And this is these steps, guys. Basically, how much is going to cost you to build this project? So remember the labor hours. We added everything else, and we decided that this project, guys, is going to cost us 956 hours, person hour. So that's the labor hours. Labor cost, now we're going to take the 956 multiply how much you're going to pay. How much you're going to pay them? I'm going to pay $53. That's your labor cost. Material, you add all your material, guys. My material came up to be $20,000. Direct job cost, I have to add a couple of permits, a couple of things for another $2,000. And an estimated prime cost is add all these together, dollar-wise, add them together. So that will get you the value here. And then overhead, let's put 30% overhead on it. And then add everything else. That will give me my prime cost. Let me show you what they did. It's easier said than done, guys. Look at this sheet. Here's what the labor hours are. Can you guys see the labor hours? Everybody see where this pulled? This 81 hours are pulled from our takeoff and laboring. Okay, then labor hour adjustment, they added, can you guys see that? They added 8% extra. Why? Because of circumstances. They add 8% extra, so this is the 8% extra. Then total adjusted, what do you guys think this one is? This one is these two numbers added together. Are you guys, I can't emphasize, this is what you guys are going to be doing for the project, so very important. Here's our, adjust them 8%, add them up. And then additional labor, they add an additional labor for whatever cause they do. They add additional labor of another 5. Then they add these up, and you end up with a total adjusted hours of 97 hours for this project. 97 hours. Any question, guys? This one is from the laboring. These are, the rest of them are adjustments. So this is step, what they call it A. This is A, step A. Just hours and adjusted hours. Step B. If you guys look at step B, it's converting, what is 97 hours? How much would cost me 97 hours? It depends on how much you're going to pay. I will tell you how they came up with this per labor hour, $10, 10.65. Step number B is converting hours into dollars. So what did they do, guys? If you take this, multiply it by 900 by 97.0, that will get you this number. Everybody can see that where they come up with this number. They multiply 10.65, $10.65. Where do they get their labor from? $10.65. They multiply it by $97. That's step number 2, converting hours into dollars. Now, if you are paying, if your shop average, we're going to talk about shop average and job average in a second. If your shop average is $65, you just multiply by $65. Questions? Questions? No questions?
You think an average of the salaries in the shop is that?
We'll talk about this. There are 2 ways of coming with this number, guys. There are 2 ways. There is a job average and a shop average. And I'll show you in a second here. Just hold it. Show you where they come up with this number. Job average and shop average. Because if I have 2 apprentices and a journeyman, the journeyman is paid $33 and the apprentice is paid $15 an hour. So which dollar per hour are you going to use? The $33 or the $15? They average them. That's the shop average. You average your crew, the dollar of your crew. So the 3 of them add 2 apprentices, 15 times 50 times 2, 30 plus 53, whatever, 63 divided by 3. 20 something, 63, 21. That will be the shop average. We'll talk about this one in a second. Okay, material. Where do you think, let me pick on somebody that I'm going to get A on where do you guys think this number came from?
G charts.
Okay, more details. Where do you think this number came from? That's from the detailed takeoff and laboring and pricing. This number is carried from material cost pricing worksheets. there's multiple worksheets, added them all up, all the receptacles, all the lights, everything else, add up to this number. So that's your total price for the whole project that you took off. Price, okay? That's what the sheets that we have before, we said we'll take them off, add them, add price to them, extend them, total them, you end up with this number. Then, miscellaneous, it's 10% just in case, dumber than a rock. Oh, did they say that? Just in case you forgot something, so you're going to add 10% safety caution, right? Here's my 10%. So what is the, how do you come up with this number? You take the 10%, 0.1, multiply it by 182.5.94, and that should give you 182.59, right? Everybody knows that? Can't believe now, because the reason why I'm going to spend some time on this, guys, because this is what you're going to be doing for this project. The same sheets, build in Excel, the same sheets. Okay, then they added, because we are in downtown Bloomington, and there's a lot of thugs and thieves down there. I'm going to pick on my hometown, right? Bloomington, there's thieves and thefts and all the stuff. We're going to add 5% for theft, just in case people stole. A cover is expensive, right? So 5%. Do you have to add 5%? Can you add 0%? Yes. Just an idea. So this is what you guys are going to be doing when you do the estimates. You're going to say, do I really want to jack up my bid price so I don't get the job because of theft? Should I take this chance of not being stolen from? So 5%, but if you are to do that, then your 5, which is 0.05, you multiply it by 1825.9, and that will get you this number. Then small tools, you need small tools, direct tools for this project, guys. So 3%, do you have to add 3%? No. So 0.03 multiplied by 1825.94, and that will get you 54.78. A gear. I have 0 gear here, guys. This is the codes. These are the codes. Right next to these, guys, this is where all your panels are going to be here, plus fixtures. Gear and code is for major equipment, generators, panels, all lights, because these are, the price can be substantially different, and you can shop around and get the best price for you. That's why they don't take a light, guys, like a receptacle. A receptacle is almost the same price wherever you go. A light could be completely different. You can, if you want to buy 200 2x4 lights, I bet you a lot of vendors will give you a lot of discounts on these 200 versus one of them. Because of this, these major electrical equipments, they put them in a list and they call them quotes. They send them to 4 vendors, you get 4 quotes, and you plug in the cheapest quote that you got. And that's how you generate your bid price. And they wait until the end. They don't give you this information till the end. Yes, sir.
If you're the project manager, do you have to, are you the one that has to take care of all the ordering?
It could be. Then if you're project manager on the project, yes. Scheduling and purchasing. You mean purchasing, buying the material?
Yeah.
Yes.
Taking care of it once it's delivered.
Yep. That's usually, why would they pay you otherwise? You know, purchasing and scheduling is big deal for a project manager. If you're an estimator, you might not be the project manager doing that. Now, the quotes, I have 0 here, guys. I think they made a mistake. I want you to write yourself a note here. I can't remember, but I think there was a number here. So say it was $1,000. Just say it was, I think if you add them up, they don't add, but I can't remember what the difference is. Or maybe $100. There's some difference between them. And then everything is added up. Then they add everything here up. Everybody's okay with that, guys? They added everything up. What's the difference, Brad? You see a difference between, yeah, they add the total before tax. This is my total before tax. Then, what's our tax? 7.5 Minnesota? Is it, or 7%? And I think in here is 7.5 maybe. They add a taxes of 7% here, and this will be your total material cost. Your total material cost. Any question, guys, about the material? That's step C. Step C, adding all the material together and adjusting it and having sales tax and quotes and so forth. FYI, you have these Excel sheet. What's the difference? There's no difference on them? Okay. but you will have a quote. You will have a quote, and they leave this slot, guys, empty until the end. When you get the quotes, the last 15-20 minutes of the bid closing time, you plug in this 100. How long will it take you to type 2,000 seconds, right? Spit the information, and everything will be tied, guys, into completely tied into the bid proposal. You send it to the bid proposal, print it within a second, you sign it, and you fax it, or you mail it, or email it, or whatever the format is. Okay, so any question, guys, about step A through C? Straightforward, right? Add all the labor, convert it to dollars, add all the material, it's already in dollars, and then direct job cost, D. Direct job cost, these are permit, any other things that you forgot to add to. A good example, as I said, direct job cost, I add another $100 for a permit, then add everything together. Add everything together. This one would be adding the 100 and the material and the labor. All these, 1, 2, 3, right? If you guys do them, that will get you your estimated prime cost. Estimated prime cost. No overhead yet. No overhead yet. Added these three together, get you $3,400, close to $3,400. Any question, my friends? So that will be my direct job cost. Moving into step E, estimated prime cost, which is right here. You're looking at it. And then step F is estimated break-even cost. Overhead. The overhead, there are two ways of doing overhead later on. You're going to either put it percentage-wise or dollar per man hour or per person hour. Here they're putting $13 on every man that I need to manage, or woman, and adding it as an overhead. So here's 13 per man hour. So here's my 13. Multiply this by $13. Multiplied by how many hours? Remember the hours for the whole project, 97 hours, and that's where they came up with this number. Okay, everybody see, guys, where they came up with this $13 multiplied by 97 hours. They came up with this 1,200. So it will cost me to manage this project. Overhead for this project, managing the labor, mainly managing labor, it will cost me $1,200. Okay, then now you add these two together and you get yourself the break-even cost. The break-even cost, now it will cost me close to $4,700 to do this job. I will pay the project manager, I will cover all my overhead and all my labor, all my material, but I will make zero money for the owner of the company, who does not carry tools, does not do anything. Zero money, unless I am the project manager who also the owner of the company. But the owner of the company will get zero money up to this point, right? Because we just paid our expenses. Here's where you're going to add your profit, guys, and it becomes the estimate. Now I want to spice it up and add some profit for the owners of the company, unless, even if you are the owner of the company, you want some profit. I added 15%. Look up the 15% on what, guys? On the total. 15 times 4, 699.00. This is where this number came from. 15% times the total. End up with, I made close to $700 profit. Where would this money goes? To the owners of the company, not the project managers, unless you are the owner of the company. So that would go to the people who own the company. $700 on this project. But just they will be sitting in Hawaii, sipping coffee and other things, and swimming and doing all this stuff, and they'll get you $700 out of this project. Not a whole lot, but if that was, imagine if that project was $10 million, that end up probably $500,000 or something just for the owners. So good money. And then you add these two together, buddies. This one here and this one. You add them, and this is the price that you're going to face the Lord with. Right? This is the one that we're going to call the bid price. That's the one I'm going to write on my proposal. I will be able to do this house for $54, very cheap, by the way. If you look at what they're doing in this house, you wouldn't be able to do it in Minnesota with 50. Imagine their whole house, taking it off in this book for 50 labor material for $5,400. And they're putting a lot of stuff on it. It's not just the phone and data and all the stuff for $5,400. I will hire them in a heartbeat if that's my house. You know. Any question, guys? Any question? This sheet is what you guys are going to be doing for your project. So if you understand it now, estimating will be piece of cake. I can't emphasize that these numbers here, this number and this number, these came from Takeoff. These are coming from Takeoff and pricing and laboring. Remember the steps of Takeoff, pricing, and laboring? These two numbers are coming from him. Then they start adjusting it, adding stuff to it. Any question, my friends? Any question? I still have some time. DJ, say something.
Something.
No, not that something.
Huh?
Not that something.
Well, just gonna say something.
There you go. Any question guys about the bid price? Bid price. This is what you're gonna face the Lord with. Go to town with, bid it. Any question? That's really, this chapter is all about this sheet. This section, all about this sheet. Yes, sir.
So have you ever been the guy that presents the bid to somebody before?
No, I've never. I'm an engineer, and most of my expertise did the
You
engineering.
don't
really.
have to bid
That big,
everything.
small jobs. I did not bid the $10 million. I designed them, but I've never been a project manager where I have to build a $10 million job. That would be really interesting.
You designed $10 million jobs?
We would design, yeah, hospitals and sport arenas and
What do you do?
I don't know. Ask myself that all the time.
You probably talk too much.
A lot of engineers don't talk.
Yeah, qualified.
You thought? Yeah.
Well, my husband works with them and say anything.
No, they're so quiet. I'm an anomaly. It's an anomaly.
Anomaly?
Is that what they call it? Anomaly when things
Yeah,
it's
that's right.
yeah, anomaly.
Out of the norm?
Out of the norm, yeah. Okay, so guys, this is what basically, if you understood this sheet, everything that we talked is really about this. Everything that we've done here is cover this sheet. So the rest of them is just explanation. Must be adjusted. Here's how you adjust your labor. Just think. Remember how we adjusted the labor? These are the things you have to keep in mind. Should I adjust the labor or not? Do I have as-built, demolition, energized part, environmental hazard, and so forth? So you can keep all your good stuff, and you can adjust an excavation, fire seal, and a bunch of other things. So just FYI, that's what you need to adjust your stuff. Labor cost, total adjusted hours can be determined. A couple of things to determine them: shop average and job average. I want to do that. I will do these things. Shop. Now, when we came up with there are two ways. Remember that $10 that they came up with, guys? How did they come up with $10? There are two ways to come up with the $10. Very interesting. I want you guys to go to page 71. Page 71. Page 71 is the shop average. Shop average. If you guys look at the shop average, Spencer, you have a company and you have multiple people working for you, your crews, and you send them to work, and you keep track of their hours on the job, their hours, and the dollars that you paid them. So, for example, in the month of April, you paid them $14,200, and their hours were 1,166, and so that gave you a rate of 12.18 in May, June, July, August, September. 6 months. Keep the track of their hours and dollars for 6 months. Then you added all their dollars, divided it by all their hours, and you came up with 10.65. See what they did? They added all the hours over 6 months that you worked on a project, and your job, you know your crews, added all these hours, keep track of their hours. That's easy to keep track of, how much you paid them, and you divided over 6 months period, and you divided how many hours how many dollars you paid them, divided by how many hours they billed you, and that will get you the 10.65.
Is that low?
Yeah, very low, extremely low. I could not believe it. This book is made in Florida, so I could not believe in.
Well, doesn't some of the southern states, you only can do
Florida.
electrician?
Yeah, you can cross the border and become an electrician. Did I say that?
Or Florida is probably.
Okay, so this is basically this is the shop average. So because I don't have my shop average, I can't find the shop average. Let me tell you, any question about shop average, keep track over 6 months of your labor hours and labor dollars that you paid, divide the labor dollars by labor hours, But remember, there's apprentices and journeyman's different rates, and you come up with a shop average rate. Shop average rate. Yes, sir.
When you get the shop average or whatever, how much more do you go over when you're bidding for it, so you actually make money when you're paying people?
That's a profit, 15%.
You go over, you
Yeah.
get 15%.
Yeah, 15% profit. There's a couple of rules, guys.
Go 30.
Yeah.
That's it.
Let me just tell you, let me just calculate a couple of ones for you guys. Let's go for, so shop average, you have to keep it easy. Keep track of your stuff. Let's look at the job average. But am I seeing it the other way? Job average rate. The job average, here's the job average. I have journeyman electrician, and I'm going to pay them. I have my journeyman electrician, guys, and I'm paying my journeyman electrician $53 an hour. Okay? With benefits, everything, including benefits. And I have apprentice, say apprentice 4, and I'm paying my apprentice 4, that would be 80% of this one, close to $40. That's close to a journeyman. These are union rates. Don't be scared here. And I have apprentice 3, I'm paying him $35 an hour, plus benefits. Plus these are including benefits, okay? And
You always include the benefits?
if you don't include the benefits in the dollars, you have to add them like we did $13 per hour.
It's 58.
No, oh. Okay, add them all up. Add all these up. Can anybody has a calculator? I'm trying to find the job average. I have a job and I'm sending a journeyman and 2 apprentices. Minimum. You can, huh? And how much?
128.
128. Now we'll look
Apprentice.
dollars. I'm going to divide 128 divided by 3. Divide 128 by 3, will you? That will give you $42.67, $43, give or take. So my job average for this job is $43. 43. When I bid it, the number, that 10 that we talked about, 10, you stick in $43. $43. That's your job. If that's what your crew, that's minimum crew. You can't. The best thing is to do is more apprentices and less journeymen, right? Dollar-wise, but you can't get more than 2 apprentices to a journeyman by law. So that's the minimum you can get, 2 apprentices by law. Now you can make your crew guys cheaper than that by hiring. We said our apprentices. Let's do it for another shop. Let's do it for a non-union shop, guys.
Or how about the actual
Journeyman.
rate?
Journeyman electrician. Yeah, journeyman electrician. Let's say journeyman electrician without benefit or anything. You're paying him $28. $28. Non-union shop. $28. I have an apprentice 1, just dumber than, not dumber, but just an apprentice, and I'm paying my apprentice $15 an hour. His apprentice probably would be making apprentice 3 at least. He knows what he's doing. Otherwise, you pay him $8. Apprentice 3, and I have another apprentice 3, 2 of them, another $15. Can you guys add these together? 15, 15, 30, 58. Take the 58 and divide it by 3. 19.3. That's my bidding price. That's what I stick in the 19.3. Based on this crew. For our project, guys, I already told you how much electricians are going to make. You're going to do the same calculation. Add them up. How many of them? I think we said 2 crews. Each one of them is going to 1 journeyman, 2 journeymans, and 4 apprentices. And I can't remember the price. And you do the job average. You stick it into the equation. Okay. So that's how the job average versus a shop average. Shop average, keep track of it. Job average, what's your crew? Most likely is going to be 1 journeyman, 2 apprentices. You don't want to send multiple journeymen because you get them, they're expensive. Any question, my friends? As I said, a lot of people guys bid there with, and then you don't add. Now remember, you're going to add overhead and profit and everything else. But a lot of contractor guys, they do it very easy. They factor the overhead and factor the profit and factor everything all in this hour, and they come up with, like a little contractor, they have $63 per hour. They're going to bid it on $63 per hour. You hear them saying $63 per hour. But remember, this includes the labor, the profit, and the burden, the everything all in one. So don't, if you see somebody saying, well, we're bidding at $63 an hour, that's because they're not adding extra overhead. That dollar is already included, the overhead, the profit, and the fifth, and all this good stuff that we added in. Any question, my friends? Any question? Mr. Rabab?
What's the job for the journeyman?
What's that?
What's the job for the journeyman? Say, journeyman takes that.
Yeah, the journeyman is the legally responsible electrician on the site. So everything that you do has to be checked by the journeyman. He's not an electrician, he's just legal, I call him legally required electrician. You have to. So if anybody, if you're apprenticeship, if you're my apprenticeship and you screw up these things and I was your journeyman, I'm liable to your screw up. Big deal. Legally, I just use the word legally required electrician on the job. So that's why you pay him a little bit extra. He might be like Chad and know nothing, man, but at least he's legally required and he has to be there to sign off on things.
Switches.
Okay. Any question, guys, about job average, job average? No?
Shop rate's 58.50.
58.50.
That's all they said.
I looked up the other day and I can't find it.
58.50. Okay. That's why I say 63. A lot of people. That's including the benefits and the profit and everything. 58.
Per
50,
journeyman.
yeah, that's about.
Everything.
Oh, that was journeyman.
Yeah.
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 58. Oh, yeah. That's just the. And a lot of people guys use, if you. Again, not science, but if you want to include, if you want to make money on an electrician, usually you have to make double what they make for you. So if I'm paying you, if you work for me, and I'm paying you 25 as journeyman, $25, when I bid the job, generally speaking, I have to bid it 550 at least to cover, at least, you know me, cover you and me, pay you and your benefits, and me and some money for me. That's kind of rule of thumb, guys.
Plus markup and profit and all that other stuff.
At bare minimum, you can do anything you want, but bare minimum. If you bid double what you pay people with benefit, don't forget about the benefits. You can, small businesses, you can make it. You don't have a whole lot of overhead. You know, you're working on a truck or something, and I pay you 28. If I pay you $28 an hour, and I bid this one by 2, they'll get me, what is that, Brad? 56. 56. Okay. Moving on to labor. As it says here, guys, NICA contractor, those are our friends, union electricians. They include these costs into the benefits are included. Like when you said, what is it, 58.50? 58.50 for general electrician. That include everything: health, insurance, retirement, everything else. Then, if you have all your benefits, then you don't have to add an overhead too is included on that one. But the 58.50 mainly is your benefits. They add other things for it when you bid. They add your overhead to it. Total material cost, we add our material cost. You can mark estimate summary, material waste. These are the things, guys. Now I moved away from the labor to the material. These are the things that you add, you adjust your material, like we did by theft. Spencer, who am I going to pick? DJ, where do you live?
Minneapolis.
Minneapolis. If you are in Minneapolis,
North side.
north, no. Or if you're in Minneapolis, we're not going to go north and south. You're going to have 15% for theft. I'm going to pick on Minneapolis today. You know, if you are in Bloomington, minus 5% for theft. People will come steal things and put it in yours. I hope you understand we're joking here. But these are how we adjusted the material, guys, based on theft and other things. Quotes, very important. The quotes, guys. Quotes is at the end. Quotes and taxes. Make sure your taxes. Anybody who knows any state that tax labor, normally material as tax, labor or not? You're gonna add your material, direct job cost, expenses like not showing the blueprints. A good example is here's a couple of things that you can add to direct job cost. Later on, you can do as-built drawing, the direct job costs. You have to redesign everything that you modified, give it back to the customer, direct job cost. Uh, all of the above. Supervision cost, whatever that means. Recycling fees, if you have some recycling fees in the area. Engineering, engineering and work drawing fees too, if you want to buy them from the engineers. You have to pay attention to that one. Prime cost, add them all up. Add the labor, add the material. And I'm just going quick with this, guys, because we just explain it on the drawing. Overhead, here's your overhead. There are two ways for overhead, percentage-wise, or your overhead percentage-wise, or dollar-wise. Dollar-wise, Mr. Mike Wolf says $13 per worker hour. And I think the percentage, what is it, 40%? I can't remember what he suggested, 40%. So, and the per man hour is better, yeah, 40%. So there's suggestion for 40% or 13. Your overhead, guys, you manage it. If you're a small contractor, your overhead is zero, completely zero, almost zero. You everything is you do. So either you suggest it by 40 or the $13 per hour. I wouldn't go with the $13 per hour though. Minimize, you're going to minimize, if your overhead is 40, that's high. They're really high. You know, in the minimum, I would, if I have to give a number, I probably would say 15% or less your overhead. The more you minimize, how do you make your overhead below, guys? By making everything billable to the project. Meaning there is not people sitting nothing. If you have people in the office, they are billable to the project directly. Break-even cost. Break-even cost. Determine how much you're gonna break even. No, you didn't gain, you didn't lose. You didn't gain, you did not lose. No gain, no loss. Any question, guys? I don't want to go to B today. Any question? Any question? So do we know now what's the adjusted, how to adjust the labor hours based on the condition, the labor cost, how to adjust our labor cost, material cost including miscellaneous waste and theft, and so forth. Switch gear, quotes, very, very important. Quotes, how to get your quotes and plug them in, and account for direct job costs, extra things that you have to account for, and how to overhead. You apply your overhead. Up to this point, we did not make money. We made friends, but we didn't make money because we're break even. As I said, break even, guys. If your company is small company, not a big deal. But if your company is big company, have owners of the company, they're expecting you to have profit for them. Rightfully so. That's we're a capitalist society. We're not sharing and carrying hands here, are we, DJ?
No, sir.
You're supposed to make profit. If you're a company, you're supposed to make profit. So that's so you need to add a little bit for your profit. Any question, guys? Any question?
You usually bill, like gas and stuff like that, in trucking terms. We usually go with this, kind of covered under the overhead, but we get them by the mile on the job usually. 40 cents a mile or something.
I'm sorry.
Like, would you bill, what would you bill like a mile if you're to do like, billing for gas and truck?
Well, they have the feds have 33, what is it, 34 cents? A lot of companies use, I want to say 34 cents per mile.
34 cents.
Yeah, I can ask because that's what we bill when we go places here. Don't we? 34, it's the feds have
Right.
34 cents per mile.
Or you can do the other way.
No? Any question, guys? Any question? I still have in this chapter, my friends, the bidding process. We'll do it tomorrow. I don't want to overwhelm you a little bit. And we do the unit price. And hopefully, if we can touch in chapter 6, that will be all we have in this chapter, in this book reading. I'm trying to kind of move through it so get you up and hyped up for the estimating this week. So at least we have an idea. The sheet that I showed you guys is exact sheet that you're gonna be working with in Excel file. There's some linking. It could be awkward at one time, Brad, so then be patient, linking them. The numbers might not be the best, but feel free to modify them. My interest is knowing the process for this project, not the product, the process. Questions? Did you sleep here as well? Okay, I'll stop right here. Go eat.